Hello students, today we are going to continue with Mathematics Paper 5 Probability and Statistics 1, and it's May, June 2025. You will be with me, Mr. Benson. Okay, question number 1 says, let your other 3 coins. The first coin, he has 3 coins. The first coin is biased, so that the probability of obtaining head when it's thrown is 0 of 3. So probability of getting head for the first coin is 1 of 3. And the second coin is biased, so that the probability of obtaining head is 1 of 4. The third coin is also, now this is fair. So probability of getting head, we know it's equals to 1 of 2, which is half. Rachel throws the 3 coins at the same time. The randomly variable x is the number of tails that she obtained. The question says, draw up the probability distribution table for the x. So we are going to start it. We know here, randomly variable x represents tail. So x represents tail. So we'll be having, since we know 3 coins will be thrown, so we'll be having 3 trials. So we'll be having first alternative with x equals to 0, meaning there will be exact 0 tail, and then we'll find for p of x equals to 1, meaning there is exact 1 tail, and p of x equals to 2, meaning there are exact 2 tails, and p of x equals to 3, meaning there are exact 3 tails. So and this is our number of alternatives that we'll be having. So we'll be having 0 tail, 1 tail, 2 tail, or 3 tail when we throw 3 coins. So we are going to find the probability of each 0, 1, 2, and 3 tail. And we literally know probability of getting head for the first time is biased, so that is 1 of 3. For the second time, head is equals to 1 of 4. And for the third time, it's fair, so probability of getting head is equals to a half. So for p of x equals to 0, meaning there is 0 tail, and we know that x represents the number of tail. So 0 tail, meaning all of them will be head. So it will be head, head, head. So it's h, 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 which will be equals to their probability. So probability of getting head for the first time, it will be 1 of 3 times. For the second time is 1 of 4. For the third time, it will be 1 of 2. So if you multiply it, it will end up 1, it's 1 of 24. Then we'll go for p of x equals to 1, meaning there are exact 1 head. Exact 1 head could be head, exact 1 tail, meaning head, tail, or head, tail, head, or tail, head, head. And we know the meaning of all, meaning you're supposed to add. So head for the first time is 1 of 3 times, for the second time is 1 of 4, for the third time is tail is half, plus 3 of 2. So head for the first time is 1 of 3, tail for the second time is 3 of 4, head for the third time is half, plus tail for the first time is 3 of 4, 3 of 2, 2 of 3, head for the second time is 1 of 4, and head for the last time, which is third time, is half. So this we're gonna keep it in the calculator. So it's going to be 1 of 24 plus 3 of 24 plus 2 of 24. So if we add up, we're going to be 6 of 24. We can keep it without simplifying. And then we'll be going to p of x equals to exact 2 tail. It will be tail, tail, head, or tail, head, tail, or head, tail, tail. So tail for the first time is, we all know it's 2 of 3 tail for the second time is 3 over 4, head for the last time is 1 over 2, plus tail for the first time is 2 over 3, times head for the second time is 1 over 4, times tail for the last time it's 1 over 2, or head for the first time is 1 over 3, tail for the second time is 3 over 4, and tail for the last time is half. Okay, this is 6 of 24 plus 2 of 24 plus 3 of 24, which will be add up to 11 over 24. And the last one will be p of x equals to 3, meaning there are exactly 3 tails. So it's t, which will be equals to tail for the first time is 2 over 3 times tail for the second time is 3 over 4, and tail for the last time is half. So if you multiply all of them, is going to be 6 over 24. So now if we draw our probability distribution for random variable x, which is number of tail, will be x number it can take. So we have 0 tail, 1 tail, 2 tail, or 3 tail. So here it's p of x equals to small x. The probability for equals to 0 head it's 1 over 24, so it's 1 of 24. 1 head is 6 of 24. 2 head is 11 of 24, and 3 head is 6 over 24. And always you have to make sure that this probability they add up to 1, for which 1 plus 6 plus 11 plus 6 is equals to 24. So 24 over 24, which is the 1. Now we'll be moving to question 2. Okay, in question 2, it say in Milford, 70% of the residents own a bicycle. A randomly sample for 160 residents is selected. So we have n here equals to 160 residents. So use a suitable approximation to find the probability that more than 120 of these residents own bicycle. We know n is equals to 160, and we know probability of success is equals to 70%. So we have to use a suitable approximation to find probability that more than 120 of these residents own a bicycle. So we know this is binomial, and we have to approximate by using normal. We need, remember in normal is always distributed with mean and the variance. So we need to find the mean and the variance from the binomial. So we remember from binomial, to find the mean, which is mu, is given by np, and to find the standard deviation is given by a square root of np q. So to get the mean, which is mu, is given by np. N we know it's 160, so it will be times by 70%, which is 0.7. The answer will be, it is 112. Again, if you take npq, so it will be 112 times q. We know if p is 70%, then q will be 30%, which is equals to 0.3. So times 0.3, it's square root 33.6. Always we are supposed to remember the standard deviation. Always we are supposed to give an exact form, so with no need of doing approximation. From here now, it's already distributed with normal, since we have mean equals to 112, and we have standard deviation given by 33.6. So we know if we draw, it will be 112. We are looking for find probability that more than 120 of these residents own bicycles. So more than 120, so we expect it 120 to be after that mean. So more than we shaded the right side. So we are looking for this area. So we know, because we are approximating, and greater than and equal or greater than is equal for normal, but for the case of binomials, these are two different. So in order to get the approximate of the actual one, then we are supposed to estimate also this 120. Since we know it's greater than 120, meaning we always have to choose whether to use upper bound or lower bound. 120 is here. Upper bound is 120.5, lower bound it's 195.5. And we remember it's greater than, meaning 120 is not included. So if it's not included, then we are supposed to use the upper side because we are looking for more than. So we are going to use the 120.5 instead of 120 exact. So in standardizing, we know Z is given by XC minus mean over standard deviation. So if we standardize, it will be XC, it will be 120.5, take away mean, which is 112, over the standard deviation, which is equals to 33.6 square root. So it's square root there. Yes, so if we keep in the calculator, it's going to be 1.639. So from the table, if we read it, this 1.639 is going to be 0.9484. We add 0.00009, so it's going to be 0.9493. And we know we are looking for the area after, so always from the table we do read the area of before, so we have to take away from 1, so 1 minus that one. So if you minus, you're going to get 0.0507 approximating 3 significant figures. So this is our answer. Okay, now we are moving to question 3. Question 3 says a bag contains 4 blue marbles and 12 red marbles. One marble is selected at random from the bag. So we have 4 blue, 12 red marbles. So one marble is selected at random from the bag. If the marble is the blue, is replaced. So for blue, replaced. But if it's the red, it's not replaced. So red, not replaced. So a second marble is now selected at random from the bag. Find the probability that both marbles selected are of the same color. So this will be nice if we use the tree diagram. So we know we have 4 blue and 12 red. So if we draw tree diagram, will be, this is for the first marble, can be blue or red. So probability of getting blue for the first time is 4 16, which is total of red and blue, and the probability of getting red is 12 over 16. For the second time, can be also red. If it's first is blue, second can be blue or red. If first was red, the second can be blue or red. Remember, here for the first one, if it's chosen, then it's replaced. So we have the same number. So probability of getting blue, again, it will be the same thing. So it's 4 of 16. And here it will be 12 over 16. While here is not replaced. So if it's not replaced, assume the first one is chosen is red. So blue will be having the same number. So it will be having 4. But the total now will be reduced by 1. So now we'll be having total of 15. And remember, the one which is selected at the first is red and is not replaced. Now we'll be having 11 red out of 15. So our question says find probability that both marbles selected are of the same color, meaning is red plus blue. So we're supposed to find probability for this. For red is 12 of 16 times 11 over 15. We'll add, for blue first time is 4 of 16, times blue of second time is 4 of 16 again. So if we keep this in calculator, it's going to be 49 of 8. So this will be our probability for same color. Part B says find probability that first marble is blue. So probability first is blue given that second, so given that second is lead. So this is conditional probability. So if we use formula of conditional probability, this is going to be probability of first blue intersection second lead over probability of second is lead. So first blue second lead, if we go up, so probability of first blue intersection second lead, we know first blue is 4 of 16 times the second is lead. Remember, if the first is selected is blue, is replaced back, so even lead it will be same thing, which is 12 out of 16. So if you multiply this, gonna turn 48 over 256. Now probability of second lead can be, the first one is blue lead or lead. So blue lead, we already get it there, so it's 48 over 256 plus lead for the first time is 12 out of 16 times lead for the second time. Remember, one is taken out, so it's not replaced for lead, so it's 11 over 15. So if we keep this also in calculator, it's 7 of 10. So if you divide them, 59 over 80. So if we divide these two, the answer is going to be 15 over 59. So this is going to be our answer. Now question 4. It says a vehicle approaching a certain road junction from Bromley must go either left, right, so it must go left, right, or straight on. Over time, it's known that 30% turn left, 25% turn right, and 45% goes straight on. The driver of each vehicle chooses a direction independent of all other drivers. Part A says, find the probability that the next 3 vehicles approaching this junction from Bromley are all going in different direction, meaning it can be the first one going left, second right, and the last one go straight. So we have to know in how many ways you can rearrange this. Remember, this is 3, we have 3 R, L, and S, so it's 3 factorial. That's a way of rearranging R, L, and S. So this is going to be 60 ways. So this can be done 6 ways. So their probability is 0.3, so times 0.25 times 0.45. So this will times it can be done 6 times. So if you times end up getting 0.24, which is in fraction can be written as 81 over 400. Now we'll be moving to part B. Okay, part B says find probability that from the vehicle approaching this junction from Bromley, today the first vehicle to go left is before 9 vehicles. So we are looking for, it's before 9, so P of X before less than 9 together. So we all know probability of X greater than R is always equals to Q to the power of R. So this one we have to turn, this is the same as 1 take away P of X greater than 8, since it starts from 80 and below. So for greater than 8, it means it's 9 and above. So this 9 is inclusive for greater than 8. So this is going to be 1 minus the Q to the power of 8. And remember, probability of success for left we know is given by 30%. So P is equals to 3.3 and Q will be equals to 0.7. So it's going to be 1 take away 0.7 to the power of 8. If we keep this in the calculator, it's 0.9423. So just to, let's go to part C. Part C says find probability that from the vehicles approaching this junction from Bromley, today the second vehicle to go left is the seventh vehicle. So meaning is in first 6, the exact one went on left, but also the seventh went left, so that is the second. So meaning is in first 6 we have exact one success, so it's 6, so now that is binomial, so it's binomial form there. So it's 6 choose the exact one success, which is probability of success is 0.3 to the power of 1 times 0.7 to the power of 4, 6 minus 1 is 5, times the success of the seventh, which was the second, which is 0.3. So it will be written like that way. So 6 choose 1 is 6, so 6 times 0.3 square times 0.3 power of 5. Then from that, if keeping the calculator, is going to be 0.8. This is approximately in 3 significant figures. So now we'll be moving to the next question. Now we're in question 5. It says the time taken t minutes by 300 students to travel to Halltown College are recorded. The results are summarized in the table below. So we can see its time in minutes. That's the first column, and the down one is cumulative frequency. So we have t less than 10, t less than 20, t less than or equals to 30, t less than or equals to 40, t less than or equals to 60, and t less than or equals to 90. And we have the cumulative frequencies, which is 34 for the first class, second is 86, third is 142, fourth is 208, fifth is 265, and sixth is 300. So on the grid, it says draw a cumulative frequency graph to illustrate this information. So we have to write this down downwards. So we know we'll be drawing using the cumulative frequencies below time in t minutes. We know the highest is 90 minutes, so we can go by 10. So it's 10 since we know 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah. And up we can go by 50. So 50, 100, 150, 200, 250, and 300. It stop. So the first class, the upper bound is 34. So the first class, the cumulative frequency for the upper bound 10 is, the frequency is 34. So 34, we have 25 here in halfway between, 30, 40, so it's 34 between them. It's after 35. 20, the upper bound is 86. So 86. 20 is 86 here. 75, 80, 86. Okay. 30, the upper bound is 142. 30 is 142. 125, 130, 135, 40, 42. 40, the upper bound is 280. So 280, 180, 105, 110, 80 to be here. When it's 60, it's 265. So 265 is, and the last one is 90 with 300. So it's just here. So if we draw this, it's this way. So now that is our curve. And down question B, it say 120 students take more than k minutes to travel to college. Use the use your graph to estimate the value of k. So they take more than, so if they take more than, it's something which is above minutes. So we have to take this, and if they are 120, it means you have to take away from 300. So 300 take away 120, which is going to be 108. So in 108th position is where we can find the 18th position is where we can find the k, which is above that minutes, is where the 120 student can travel to college. So 108, 175 is halfway between 150 and 200. So 108 is next R. So it's here. We draw the line straight until here. Then we draw down here. Then this is 32, 34, 36. So this is 35. So our k is equals to 35 minutes. We are done with that. So we are going to part C. Part C says calculate the estimate of the mean and the standard deviation of the time taken to travel to college by the 300 students. So we know those are what we are given there is the upper bound. So for the first class it was t less than or equals to 10, t less than or equals to 20, t less than or equals to 30, t less than or equals to 40, t less than or equals to 60, t less than or equals to 90. So the first was 0 to 10, first class. The second was 10 to 20, 20 to 30, 30 to 40, 40 to 60, 60 to 90. And their frequencies, we have to find frequency after we minus the frequency before. So we'll start 34. So the first one will be 34. The second will be 86. We take away 34, which will be 52. 142 take away 86 will be 56. 208 minus 142 will be equals to 66. 256 minus 208 it will be equals to 57. And 300 minus 256 it will be equals to 35. So from here now we can consider this to get our meaning, whatever. So we know the midpoints. We'll find the midpoint there will be 5, 15, 25, 35, 50, and here it's 75. To get the mean, we know mean is given by the summation of fx over summation of f. So summation of f of x, it means 5 times 34 plus 52 times 15 plus 56 times 25 plus 66 times 35 plus 57 times 50 plus 35 times 75. Summation of the frequencies, they all add up to 300. We know that. So our mean is going to be at 3.8. Now standard deviation, we know it's summation of fx square over summation of f minus mean square root. So if we find summation of x square, will be we square the x while we are timesing the frequency. So 5 square times 34 plus 15 square times 52 plus 25 square times 56 plus 35 square times 66 plus 50 square times 57 plus 75 square times 35. This over 300. Okay, the answer, we take away that 3.80 square, then the final minus 33 point is going to be 20.4. minutes. So our standard deviation will be 20.4. Now we are moving to question 6. Part A says, find the number of different ways in which the 10 letter in the word amalgamate can be arranged so that there is M at the beginning, M at the end, and there are no S's are together. Meaning there are supposed to be no more than 2 A's are coming together. So we know exactly we have 10 positions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know at the end we are supposed to keep M and the beginning M. So M, M. And we'll be having the rest of the position there. Since condition says M at the end, M at the beginning, and no S are together, meaning is we are supposed to lay down all that we can keep them together. So we know what can be together from the rest there is L, G, M, and T. This is what can be all together. We know the positions that we can keep those A's is we have to count them. So except M, so keep M like it's this way and M is at the last. So the positions that we can keep those A's so that they cannot go together, it's this position, this position, this position, this position, or this position. So we now have 5 positions that we can keep as those 4 A's. So we are going to arrange in 5 positions. We are going to arrange 4 letters. So it's 5p4 will times with the number of times that we can keep. We can arrange this list, which is L, G, M, and T. So since we have 4 and there are no repeated, so it's going to be 4 factorial. And since we know that these A's are of the same kind, then we have to divide the whole thing by 4 factorial. And then this we can just keep in the calculator. And the answer is going to be 120. So there are 120 way of arranging that name, amalgamate, and M at the beginning, M at the end, and there are no A's are together. Now we can move to B. Part B says, find the number of different ways in which the 10 letter in the word, the same word amalgamate, can be arranged with exact 3 letter between 2 M's. So the condition now is between 2 M's, we are supposed to keep exact 3 letters. So same thing, we are supposed to count how many positions we can keep the letters. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in 2 M's it has to be exactly 3 letters. So we have to keep M at the beginning and we skip 3 space for other letters and then we keep another M. And that will be the exact 3 letters to keep between 2 M's. Then we have to see how many ways we can arrange the rest of the letter except this M. So we have 8 left. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 80 factorial. In this 8 factorial, we know we have 4 A's. So 4 A's of the same kind, we have to divide by 4 factorial. With times by the number of times that we can keep on shifting those M's, and still it will be making the exact 3 letters between M's. So this is the first. This is first. Second will be this way. So this will be second and this will be third, fourth, fifth, sixth. So it will be 6. So times 6. So if you keep in calculator, the answer is going to be 108 ways. Now we can move to C. C says 5 letters are selected from the 10 letter in the word amalgamate. The word is amalgamate. Find the number of different selection in which the 5 letters including at least one M and at least 2 A's. So condition is in M. So at least 1 M and at least 2 A's. So we know we have 2 M's. We have to draw the box. 2 M's, 4 A's, and the 4 others list. Okay, we know we need to have at least 1 M, at least 2 A's, 2 M's. We did probably have 2 M, 4 A's, and 4 others. So to make 5, we can choose 1 M, 2 A's, and then we'll need 2 more. If we use 1 M, we use 3 here, we'll need 1 more. If we use 1 M, all A's, we'll need 0 more. If we use double M and double A's, we'll need 1 more. And if we use double M and triple A's, we'll need 0 more. So here we cannot select from 2 M's because it's the same thing, and also we cannot select from A's because they are the same kind. So we select from the other. So from 4 we choose 1, and there from A's it will be just 1 1. So 1 1, so it's 4. Plus from here 4 we choose 1. From 4 we choose nothing. Or from 4 we choose 1. Or from 4 we choose nothing. So 4 choose 1 is, so the first one was 60. 4 choose 1 is 4. 4 choose 0 is 1. 4 choose 1 is 1. 4. 4 choose 0 is again 1. So we take 60 plus 4 plus, so it will be equals to 16. So there will be 16 ways. Now we can move to the next question. Okay, now we're in question 7. It says kestrels are birds whose adult wingspans are normally distributed with mean 74.8. So our mean, which is mu, is given by 74.8, and the standard deviation is 3.2. A random sample of 120 adult kestrel is selected. How many of this 120, so n equals to 120, will be expected to have the wingspan between 72.4 centimeter and 76.3 centimeter? We know this is normal distribution, so we are supposed to first thing to standardize. So we have between 74, so it's p of 72.4 less than x less than 76.3. So we know if we draw this is this way, it's between. So this is A and this is B, so it's A, B. We are looking for this area between. So we can start standardizing. So this is 76 minus 0.4 minus mean, which is 74.8 over standard deviation 3.2 less than x less than, above it will be 76.3 minus 74.8 over standard deviation 3.2. If you keep in the calculator, it will be equals to negative, so it's psi of negative 0.75 less than x less than, this is going to be so 0.46875. Then this will be equals to psi of the above 0.46875, take away this below, which is negative, so it's 1 minus psi of 0.75. So this is, if you read in the table, this is going to be 0.6804 minus If you read this is 0.2266. So if you minus this from each other is equals to 0.4538. Remember we asked for how many of this 100 are expected to be that, so we times by 120 will be equals to 0.4538 times 120. It will be 44.4 something, so it's 4 or 55. Okay, now we go to part B. It says the masses of adult cholesterol are normally distributed with many mu, so mu mean, standard deviation. It's known 20% of adult cholesterol have a mass greater than, so P of X greater than 0.202 is equals to 20%, and so this is A, and B 28% are less than, so P of X less than 0.185 is equals to 28%. So for A, first thing we can even get the Z. We know this is, if we draw, it's normally always you have to draw so that you understand whatever you're going to get. So this is 20% and it's above, it's greater than, so we start shading light side. So 20% it won't exceed even the halfway, which is mean, so we expect it to be here, and this is 20%, so it's in positive side even if you standardize. So our Z is going to be the inverse of 20%, which is, for 20% you cannot find inside the table, so you are supposed to, because this we are supposed to inspect inside the table. So inside the table the smallest is 0.5, so we are supposed to check for 0.8, which is 1 take away that 0.2, so it's 0.8. so the inverse of that, that is going to be 0.842. so this will be equals to, if we standardize, 0.842 equals to X, which is 0.0202, take away mean over the standard deviation. So multiply standard deviation, Z will be 0.842 standard deviation equals to 0.202 plus, no, minus standard deviations, minus mean. Mean moves this way, it will be mean plus 0.842 standard deviation equals to 0.202. This is first equation. For case B, it's Z equals to, we are supposed to get the third inverse for negative, for 28 also we cannot find inside, so we have to take it away from 100%. This is, so it's 0.72. If we draw this is this way and it's less than, we start shading this way. 28% cannot exceed even, so this is 28, cannot exceed the mean, so it's here. So this is, if we standardize, is negative, so the inverse of this has to be negative, so it's negative, whatever will get 0.583, then equals to, if we standardize that, it will be our X value, which is 0.185, take away mean over the standard deviation. Standard deviation multiplied there, if you add, so it will end up mean, take away 0.583, standard deviation is equals to 0.185. That is the second equation. So we're gonna solve them simultaneously. So the first is mean minus 0.583 standard deviation is equals to 0.185, and the second is mean plus 0.842 standard deviation is equals to 0.202. First you can minus, this way you will get equals to 1.4. This, since this will cancel, 1.425 standard deviation equals to 0.017. If you divide both sides by 1.425, standard deviation is going to be 0.0119. And to get the mean, we know we are going to substitute it, so mean is going to be equals to 0.202 take away 0.842 times 0.0119. So our mean is going to be equals to 0.192. So this is done and this is done. So now we're going to last part. It said 10 adults cases are selected at random. So our n is equals to 10. So find probability that fewer than p of x less than 3 have masses greater than that mass. We know if we go up here for the mass of greater than 0.203 was 20%. Okay, so probability of success is 0.2, so p is equals to 0.2, and this is what we are looking for. So we know q will be equals to 0.8. So for less than that, we are supposed to find for less than that is equals to 0 plus equals to 1 plus equals to exactly 2. So exactly 0, it will be 10 choose 0, probability of success 0.2 to the power of 0 and 0.8 to the power of 8 plus power 10 plus for exact 1 10 choose 1, 0.2 to the power of 1 times 0.8 to the power of 9 plus 10 choose 2, 0.2 to the power of 2 times 0.8 to the power of 8. So if we keep this in the calculator, the answer is going to be approximate to 0.678. So this is our answer. We are done with this paper. So you're welcome another day.